All right. You doing well with this stuff so far?
Yeah, I think so.
All right. For some reason, this Jamboard takes a long time to load these days. I don't know why. So what's the hardest thing for you so far for this unit? Like, what's the thing you're most concerned about or confused about?
Probably just like the sine cosine functions.
Graphing?
Mm-hmm.
Okay. All right, so a Ferris wheel has a diameter of 50 and it takes 6 minutes to complete a revolution. So 6 minutes means that's the period, right?
Mm-hmm.
Period equals 6 minutes. And then diameter of 50 feet means that the diameter of 50 feet means that the A equals 25. Going to be half of whatever the diameter is. Do you understand why? Okay. And then it says they bored from a platform 12 feet above the ground. That means that your D is 12 because they're going to board. I mean, I guess it's kind of hard to tell because are they boarding at the very bottom of it? That's what they didn't really say, right? If they board at the very bottom of it right there, that's where they're boarding, then this distance is 25 to the center, right? And that distance is 12. And so your base, like the bottom is going to be 12, and the midline is going to be 25 plus 12.
Yeah.
Which is 37, right? And then 25 more from there would put you at 62.
Which is the max.
Which is the max, right? So that's most likely the situation.
Yeah, that's how we usually do them.
Okay. So it says, what's the max height that you will reach? Well, that's 62, right? Makes sense? How many minutes will you first reach the max height, and how many minutes?
3.
Good. That'd be half of a revolution, or the half of a period, rather. Revolution, same deal in this case. So 3 minutes, assuming you're not stopping, of course. What is the equation of the midline? So this is your y equals 37 right there. That's your midline, right? So y equals 37, because y equals is a horizontal line, right? What's the amplitude? 25, right? Understand that? How high off the ground will you be after 15 minutes? So this is one where you're going to now have to plug this into your equation. Or you could just kind of do math on it, right? You're going to be 6 minutes, you're going to be back to the bottom. 12 minutes, you're going to be back to the bottom. So now we're 3 minutes after that. And again, this is all assuming it never stops.
Yeah.
Which they didn't really say whether it did or not, but I guess we can assume that. So 6 minutes, you're at the bottom. 12 minutes, you're back to the bottom again. And so 3 more minutes, you're going to be back to the top. Right? So how high off the ground you'll be? 62 feet. That's the easiest way to do it. But if it was a question like if they said, how high will you be after 14 minutes? Then it wouldn't be quite so easy. Then you'd have to write your equation, y equals a times, let's see, we're starting on the bottom, so it's going to be a cosine, right? So it's going to be a negative cosine.
Yeah.
Right? Negative cosine. Your period is 6, which means that your b equals 2 pi over 6, which is pi over 3. So cosine pi over 3x plus 37. No, plus 12. Because d is 12, right? Because you're starting at the bottom. So what you would have to do is plug in right? Yeah, you'd have to plug in 4. So one way you could have done this is after 6 minutes, how high will you be? Now when you plug in 6 here, you get negative 25 times the cosine of 2 pi plus 12. And the cosine of 2 pi is like the cosine of 0, right? And the cosine of 0 is 1. Negative 1, no. Cosine of 0, cosine is your x coordinate, it's 1. So why is it negative 25? Not negative. I'm just trying to think of why I made it negative 25.
Because of it's like the cosine usually starts at the top, right? But it's starting at the bottom.
I know, but it's not working when I do this, because when I plug that in, I get negative. I'll get negative 25 plus 12, but I should get 62 when I plug in 6. Oh, I'm sorry. I wasn't plugging in 6. But still, that's not right, because I'm going to be at a negative. I'm going to be at a negative value. I should never be at a negative value.
Yeah.
So something I didn't do right here. Something with my formula is not right. Let's see. I should not have been plugging 6 in here. I should have been plugging 15 in there. So that would have been 5 pi. Right? If I plug in 15, that becomes 5 pi, and the cosine of 5 pi is okay. Well, I don't like this negative 25. Something's not right about that. Let's think about why. Why is that not right? Let's think about sketching the graph and labeling the axes. So I'll do this over here. Something's wrong. And I'm not seeing it. So we have, here's 12. That's the lowest you'll ever get is 12. The highest you'll ever get is 62. And the midline is right in between there, which is y equals 37. That's all correct. Your height at 0, like this 0 right here, your height at 0 is going to be there. And your height at 6 is going to be there. And your height at 3 is going to be there. And your height at 1.5 is going to be on that midline. It's going to be on this midline. So your graph looks like this. Okay. But yeah, I think this 12 should not be 12. I think this 12 is supposed to be 37. Yeah, it is. It's supposed to be 37.
Why?
Because the normal graph, your cosine graph normally goes from +1 and -1. Your cosine graph normally does this. It will go like this. There's 2 pi, there's pi, and there's 0. Your sine graph, it goes up as high as 1 and down as low as -1. So if you start down here and end down here and max out up there, you see how your midline? That's what your normal cosine graph looks like.
Yeah.
So D was not 12. The low point was 12.
I
right?
see.
So
Yes.
D is the midline. That's your midline 37. And now it'll work. Because now when I plug in 15 and the 3, I get 5 pi. And 5 pi is like this. Here's my unit. Think of your unit circle.
Yeah.
Here's 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. So 5 pi is over here, right? Which is -1. The cosine of 5 pi is -1. And -1 times -25 is +25. And I add 25 and 37 and I get 62 top point. Make sense?
Yes.
Okay. And that's also, by the way, why if the problem was a little bit harder, they would say, what's the height? Instead of after 15 minutes, they could say after 14 minutes. Well, then you could just still plug it into here and you'd have to use your calculator. What's the height after 14 minutes? Then you take your calculator, make sure that you're in radians, not degrees. And your formula is going to be 25 cosine of 14 pi over 3. 14 pi divided by 3 plus 37. Give me an estimate of how high you think it's going to be.
Probably in between 37 and 62.
Perfect. You know it's going to be in between, probably closer to 62, right?
Yeah.
Good. So let's see. A little bit closer. Kind of right in between them. So yeah, good job. Perfect. Makes sense? So there's the equation for the model. I just wrote it right here. There's the equation.
Yeah.
Okay. Good with all that stuff? Find a positive and negative coterminal angle for the given angle. Remember doing this?
I know how to do that. Yeah.
All right, good. How about this next one? How about for 500?
Positive, you just subtract.
Good, because you'll still be positive.
Because they'll still be positive. And then
so that's going to be what, 140?
Yeah.
And then for the
negative, you just subtract 360 from that.
There you go. Good job.
Easy.
All right. Find the arc length. Remember formula for arc length? What is it?
Arc length. S equals R theta.
Good. And theta has to be in?
Radian.
Perfect. And is it in radians yet?
No.
For number 3? No. So what do you have to do?
You have to multiply by pi over 180.
Good. Or you could just recognize, hey, that's on my unit circle.
Oh,
this
yeah,
is just down here. That's just 3 pi over 2.
Oh, yeah.
Right? That's going to be 3, and that's going to be 2.
Oh my gosh, easy.
So then what's S?
S is going to be 13 times 3 pi over 2. Oh my gosh,
equals?
wait, Mr. Dwyer, happy Pi Day.
Oh, thank you. You're the first person to say that to me. Wait, that's tomorrow. No, it's today.
It's today.
Oh my gosh, you're right. It is today. No, how did I not hear that at all day today?
Yeah, you're like a math guy.
I am. I'm just like a math guy.
Ugh, crazy. Then it's gonna be.
Can I cancel these at all?
That in my head.
Let's just multiply them.
Yeah.
13 and 3. 13 times 10 is 30. I'm sorry. 10 times 3 is 30. 3 times 3 is 9. So it's 39. 39 pi over
Pi
2
2
feet is your answer.
Okay.
Hey, is 39 over 2 simplified?
No.
Why?
No.
Why do you think it's not?
Because 39 is like weird. It doesn't have any friends.
So it is simplified.
Yes.
Okay, good. Yeah, it is simplified. And hey, you know how you know? Because 13 and 3 are both prime. So you can't break it up. If you could have canceled this out with the 2, you would have canceled it here.
Yeah, wait, does prime just mean like can't cancel out? Like there's no like factors?
Prime means there's no
like,
other yeah, one in itself. Yep.
Okay.
How about number 4? What are we gonna do for number 4?
Number 4, it's already in radians. You can just do S equals 14 times 17 pi over 12.
Good. Should I multiply 14 and 17 together right now? Big fat no.
Yeah, no, because 17.
Because let's simplify before we complicate. What can I do with 14 and 12? This is like 14 over 1, right?
Those both can get divided by 2.
Yep.
So you have 7 and 6.
Now can I multiply them together?
Yes, because now
here, let's do this in our head. Ready?
Okay.
7 times 17 is like 7 times 10 plus 7, because that's 17, right?
Oh.
What's 7 times 10?
70.
And what's 7 times 7?
49.
Good. And what's 49 plus 70? Take 30 from this. Take 30 from it. I'm taking 30 and making it 30 and 19. Why would I do that? Why would I think of this as 30 and 19?
Because the 70 and 30 make 100, and then you just add 19.
Done. See how you could. That's how I think about that in my head. That's how I do that problem in my head.
It's a good thing to know.
The more you do it, the quicker you get. Yeah.
Yeah.
So it's 119 pi over 6. And can I reduce that? The 119 and the 6?
I don't think so.
Why do you say I don't think so?
Because 119.
How about you just say, I know you can't? What's
I know 119? You can't.
119 is just what?
7 and 17.
Yeah. And do they have any factors that are the same as 2 and 3? They do not. That's how you can know.
Disappointing.
You have to worry.
Yes.
That's why you can say no. You can't simplify it, because if I could have, I would have simplified it before I complicated it. That's why I say simplify. Right here, 14 and 12. Don't multiply 14 and 17 together, because then you have to divide it back out again.
Yeah.
This is just break this up into its prime factors, right?
Yeah.
This is 2 times 7. This is 2 times 6. So the 2's cancel out, and you just get 7 over 6, right? 17 is a prime number. So you're done. Next one. On a merry-go-round, you stand 15 feet from the center while your friend stands 10 feet from the center. How much further do you travel in one revolution than your friend? Stand 15 feet from the center. Oh, got it. I'm thinking Ferris wheel. Merry-go-round. Got it. Merry-go-round. So here's the merry-go-round. And here's the center. You are standing 15 feet. This is you.
Me. Okay.
And your friend is standing 10. Actually, let me make it a little bit bigger. That's 15. And your friend is only 10. How much further do you travel in one revolution? Well, one revolution is like the circumference, right? The circumference circumference just equals pi times the radius. So you are going to travel.
Oh, this is easy.
Yeah.
15 pi and 10 pi.
For you is 15 pi. And the circumference for your friend is 10 pi.
And
I'm
you
sorry.
go 5
hold on,
pi.
hold on. Pi r. It's 2 pi r. My bad. Not pi r.
Oh, well, even so, that doesn't make it much more
still
complicated.
easy. 30, 20. That's how far you travel, 30 in one revolution.
Mm-hmm.
Right? And
yeah,
she travels 30 pi and 20 pi. Give answers in terms of pi and rounded to the nearest foot. So they want 2 answers. How much further do you travel? You
10
travel
pi.
10 pi more, which is 30 point, point, 3.14 times 10 would be 31.4 pi. I don't even need a calculator.
Oh my gosh, crazy.
I'm sorry. I just said pi. 30.4 feet or 10 pi feet.
Yes. It's Pi Day.
Cha-ching.
Pie,
yeah, it's Pi Day. On Pi Day.
Crazy.
All right, last page. Which expressions have the same value? Well, for cosine, here's how I think. Cosine is your y coordinate, right? Mm-hmm. So this is plus. This is plus. This is minus plus. Right? This is minus. And this is plus minus. So where are the cosines the same? In the first and the fourth quadrant is when they're the same.
Oh.
Right? So 5 pi over 6. Here's 5 pi over 6 is in what quadrant?
Second.
Good. And where's 7 pi over 6? There's 5 pi over 6. There's 7 pi over 6.
That's third quadrant.
Right?
Yes.
And negative 7 pi over 6 is the same as positive 5 pi over 6, isn't it? Because you're just going this way.
Oh, yeah. That's crazy.
So really, all 3 of them are the same.
Oh my gosh. So it's like a trick one. Okay.
It was kind of a trick question-ish. Mm-hmm.
It is.
So they all have the same because they all are negative. The y coordinate, that this is your cosine, is this y coordinate right here. Sorry, x coordinate.
I see.
Make sense?
Mm-hmm.
Which function represents the sine curve shown to the right? Well, let's take a look. First of all, notice that it starts in the middle and it goes down. So it's going to be a what? Meaning negative. If it goes down, it's going to be a negative. So that means these aren't the right answer. And the only other question is, what's the period?
2
Let's
pi.
see how long it takes us to get back. The period is pi.
Oh, the period is pi. This is crazy.
So what does that mean about B?
It's 2.
B equals 2 pi over pi, which is?
2.
So what's your answer?
A. I can't believe we're getting rid of pi on Pi Day in that problem. That's a little rude.
Very rude. Got it?
Yeah.
Got more?
That's
we cruised through those ones pretty good.
Mm-hmm.
Nothing else?
Yeah, that's it. I don't get my other review till tomorrow. So.
All right. Well, let's take a look. Let me take a look at my schedule. I can definitely do it. It's just a matter of I might just do it later in the day.
Yeah, that's totally fine.
Like later, like 9 o'clock or something. Is that
9 o'clock? I'm in bed by then. I'm kidding. No, I'm not.
That's why I'm saying that. Is that okay? Because my wife is in bed by then.
Nah, it's fine.
Let's go 9 o'clock because that'll give me enough time.
Yeah, for sure. 9 o'clock on Wednesday.
So just let your mommy know that I'll set up a session for you.
Yeah.
I'm gonna add one and just go ahead and jump on and grab it.
Sweet.
Sound good? Hold on one second. Let me just close this.